All right, let's get right into it. We are living in a world that is just completely powered by artificial intelligence now. It's this incredible tool, right? But for most of us, it's a total black box. We put stuff in, we get stuff out, but what actually happens in the middle is a complete mystery. And that, right there, raises a huge question. How do you control something you can't really see? And that's really the heart of the problem, isn't it? We're being asked to trust these systems with everything, our personal data, our medical info, even our money. But without some serious frameworks for security and accountability, we're basically building our future on a foundation of sand. That makes it super vulnerable to failures, misuse, and honestly, a total breakdown of public trust.
I mean, this slide really just lays out how high the stakes are. On one side, you've got this incredible promise. We're talking mind-blowing efficiency, innovation, maybe even solving some of our biggest global problems. But on the flip side, the danger is just as real. Systems we can't see into that can be exploited and that could undermine the very trust they need to even work.
So, to deal with this massive challenge, a really fascinating two-front war is starting to take shape. One front is being fought from the top down, in the halls of government with geopolitics and regulation. And the other is being fought from the bottom up, with technologists actually building trust directly into the code that makes these things tick.
Okay, so let's tackle that first front, the geopolitical approach. The easiest way to think about this is like controlling the raw ingredients of AI. It's all about governments making big decisions about who gets to play with the most powerful AI technologies. And, maybe more importantly, who doesn't.
And the main weapon on this front? It's a rule from the U.S. Department of Commerce with a pretty telling name, the Framework for Artificial Intelligence Diffusion. And its goal is super clear. They're not hiding it. It's to stop adversaries from building their own advanced AI by cutting off the supply chain.
And here's how it works. It's actually pretty clever. The policy has two main parts. First, it puts export controls on the model weights. Think of those as the secret sauce of an AI, the crucial numbers that make it smart. Second, it restricts access to the powerful semiconductor clusters. These are the super specialized computer chips you absolutely need to train these giant models. So basically, you control the recipe and you control the oven.
Now, this isn't the U.S. just going it alone. The policy basically creates a tech alliance of friendly nations who all agree to help prevent these technologies from getting into the wrong hands. And as you can see from this list, we're talking about key partners, which makes it obvious this is as much about foreign policy as it is about technology. So while all that top-down government action is happening, there's a whole other battle going on from the bottom up, deep inside the tech itself. This is the technical approach. And it's all about embedding things like integrity and trustworthiness right into the AI's DNA.
This old proverb just nails the whole vibe of this technical front. It's not good enough for an AI company to just claim their model is fair, or private, or accurate. Nope. The goal here is to build systems where anybody can actually mathematically verify that those claims are true for themselves.
So what exactly are we trying to protect here? Well, some really interesting research from MIT points to two major threats. On the left, you've got internal attackers, people who could mess with the system from the inside. And then, of course, you have external attackers trying to break in. And what are they after? You can see it on the right, the really valuable stuff, our sensitive training data, the company's secret model weights, and our private user prompts.
To defend against those kinds of threats, the work is really focused on three core pillars. First up is privacy, making sure our sensitive data doesn't get leaked. Then there's verifiability, which is that ability to mathematically prove that what the AI company says is true actually is true. And finally, auditability, which gives us a kind of breadcrumb trail to follow so we can understand exactly what the system did and why.
Now, I know this all might sound a little bit abstract, but there's this one specific technology that makes it all possible, and it almost sounds like something out of science fiction. You could call it a cryptographic truth serum for AI.
It's called a ZK-SN ARC. Yeah, it's a mouthful, I know, but the idea behind it is absolutely revolutionary. It's a type of cryptographic proof that lets you demonstrate that something is true without revealing any of the secret information that makes it true.
Okay, think of it like this. Imagine you could prove to a website that you know your password without ever actually sending your password over the internet where it could be stolen. That's the kind of magic we're talking about with these zero-knowledge proofs. You prove the fact, but the secret itself stays safe.
So how does this work for AI? Well, a company can take its super-secret valuable AI model and prove how well it performs on some public test. They can generate a tiny little cryptographic proof that mathematically guarantees the results, all without ever having to show anyone the secret model itself. It completely separates the proof of how good it is from the secret tech that makes it good.
And here's the best part. This lets any user, anyone, issue a challenge. You can get a response from an AI and say, hey, prove to me you actually use that super powerful model you advertise, and not some cheap, watered-down version. The provider can then generate a ZK snark just for your query, proving the integrity of the model they used. It is literally trust but verify in action.
Okay, let's zoom back out. We've got these two really powerful forces at play, right? We have the top-down government policy that's controlling access, and we have this bottom-up cryptography that's ensuring integrity. So how do they fit together?
This slide does a great job of breaking it down. Policy is the what. It creates the rules of the road, it sets those geopolitical lines, and it controls who gets access to powerful AI in the first place. But the code is the how. It provides the actual tools for trust, letting us build safer systems and ensure the integrity of the AI that's operating within those rules.
And that right there is the main takeaway from all this. These strategies aren't fighting each other. They're two sides of the same coin. You absolutely need both of them if we're going to have any hope of navigating the future of AI safely and building systems that we can actually, genuinely trust.
So I'll leave you with this question to chew on. As we move forward into this new era, what's going to be the deciding factor for creating a safe AI world? Is it going to be the high-level laws and policies that we write? Or is it going to be the fundamental trustworthiness that we manage to build right into the code itself? The real answer is probably both, but the balance between them, that's what's going to define the next chapter of technology.